They could have some really good games and some really bad games. Doesn't really tell you much about what kind of players they are, besides the fact that they're not consistent. All right, last one is, this is the one that you guys did not learn before. The difference between finding, go ahead. The difference between finding sample standard deviation and population standard deviation is you divide by n minus 1. That's okay. I said this is the new thing a moment before I actually did the new thing. You're right. This was done. This wasn't. No, I said it wrong. I actually thought to myself as I said it, oh, I said that a moment early. They're not going to mind. And Noah's like, actually. I'm like, I would have too. Okay, so you divide by n minus 1 in a sample standard deviation instead of a population standard deviation. The reason why, Georgia, it's a hard thing to understand, but basically, like, you have to imagine that you probably, in a small sample, don't have the outliers. You don't have the person, like, you think, like, wow, 9 cats is a lot of cats. I bet you there is a farm close by that has way more barn cats than 9, right? We just don't happen to have that person in this class. And we don't have the lots and lots and lots of people who would say 0, right? So we don't have these balancing out. So we assume that actually it probably would deviate more than what ours is, which is why you divide by 1 less, which is the best example I can give you. Okay, now, what we did not learn how to do before was we didn't talk about how to do a grouped population standard deviation. So, let's see, 1, 2, 3, 4, 5, 6, I think it's 6 across. And we're going to go 5 down. We're going to use that data that Nathan made up. As a reminder, this was 50 data points. Now, if we were really, I'm sorry, I'll give you time. If we were really thinking about this data set, like if we had all these numbers in front of us, I want you to visualize this. Do you guys see that there would be 50 numbers in front of you? How many of them would be zeros?
22.
22. You'd have 22 zeros in front of you, then there'd be 14 ones, and that there'd be 5 twos, 3 threes, and 6 fours. Everybody see it in their head? Okay. So when we're thinking about a deviation, the zeros are weighted way heavier than the 4s, right? Because there's way more zeros than there are 4s. So first thing we're going to do is find a weighted mean, which is exactly what we did before. I'll just write these down quick for us, which means we multiplied x times f to find our weighted mean. If you add them up, you get 57. And to find our weighted mean over here, we took 57 divided by 50. Which was 1.14 cats, or as we have discussed, 1 cat and some cat fur. Probably. This is our mu. This is our mean. Okay, now we are going to find the deviation of each entry from the midpoint. Now, in this one, this is important, so focus on me now. This one is really easy because we only have one number here, but imagine this was a category. Imagine this was like 0 to 2 cats, 3 to 5 cats, right? The number you would use as your x is the midpoint of a class. In this one, it's really easy because we've just got these two right here. So we're going to find the deviation of each one of these from the mean. So now we've got x minus mu. Then we're going to take x minus mu squared. So this first one is negative 1.14. And then what? Negative 0.14. It's going to be really apparent fast if you're looking at the right thing. Do you see how 14 would be like 12.86 above it? That's because this is how often it happens. We're looking at this one, the x minus mu. So you're taking 1 minus 1.14 right now, and then 2 minus 1.14. So this one is 0.86 above. This one is 1.86 above. This one is 2.86 above. Then we square them all to make them positive. But this doesn't take into weight how many are in each category, right? This just, I mean, besides the fact that this is a weighted mean, all this says is that we are, you know, this below that mean, this below that mean, this above, this above, this above in these categories. But it doesn't take into account that there's lots of different numbers of people in these categories. So now you're going to multiply the squared deviation times the frequency to give a weight to it. So the first one is 22 times 1.3.